And then, oh, it's going. Oh, I better say something. Their computer screen. All right. So, anyway, when you are doing quotients, okay, or we're finding zeros of polynomial functions, and this thing here is this holds true for polynomial functions as well as for anything when you're doing like long division. For instance, if I had something like this, where I have, say I had, how come it's not writing? Say I had like 3 divided into, I don't know, 28, right? How many times does 3 go into 8? 23 go into 28? 9, right? And 9 times 3 is 27. And I subtract, and I get 1, right? And then you bring down the 0 here. But this is also the remainder. So when I divide 3 into 28, I get 9 remainder, 1/3, right? Or 9 and 1/3. So this thing here is called, the thing that you divide into is called the dividend. Dividend. I'm just trying to show you this because this works exactly the same with numbers as it does with polynomial functions. The thing that you divide by is called the divisor. I hope I have these straight. I think I do. The thing that you get when you divide is called the quotient. Remember that? Quotient. And this thing here that's left over is called the remainder. Okay? And just like with the number, when you're dividing two numbers, the remainder is this over this. So the same thing happens with long division. Then it kind of works backwards. So if I were to cross multiply through by g, right? If I were to cross multiply g of x, I would get q of x times g of x equals, or plus r of x equals f of x. And that's kind of, this is kind of just the same thing as this in a different form. Okay? But that has some applications when you're dealing with polynomial functions. Okay? So you have all these rules, but they're not that bad. Okay? The first one, and I know someone else told me that they did this in both Mrs. Bravo's and Mrs. Shannon's class. Didn't you? Synthetic division? Yeah, so that's kind of what this is about, okay? And what this is called the remainder theorem, okay? Which it kind of comes out of this, because if I multiply the quotient, right, times the divisor, and I get what's left over is called the, well, that doesn't make sense. This end part is called the remainder, but if I don't get a remainder, well, never mind. I'm bad with it. Okay? I'll just tell you what's important. Find the remainder. So what you do is you take this and you plug this into here. Okay? So when you plug the 3 in there, you get, what do you get? You get 27, right? Is that right? Yeah, positive 3. You're not plugging in negative 3 because if x minus 3 is a factor, then f of 3 will give you the remainder. So you get 27 minus 4 times 3 squared, which is 4 times 9, right? 36 minus 5, which gives you 27 minus 36. Negative 9 minus 5 gives you negative 14. What that means, if I did a long division and I were to divide x minus 3 into x cubed minus 4x squared minus 5, I'm not sure what the quotient is. We'll talk about that in a minute. But the remainder would be negative 14, okay, over x minus 3, okay? So then if I want to find out the remainder here, what do I plug in there? Negative 2, because it's x minus c. So minus means that this must have been a minus. So to find the remainder in this case, I plug in negative 2. So don't forget you go like this. Negative 2 cubed minus 4 times negative 2 squared minus 5. Like that. So if I were to divide by x plus 2, my remainder would be negative 2. First you square this, which makes it positive 4, times negative 4, which gives you negative 16, right? No? I knew that. That's negative 8, right? And this is minus 5. I'm tired. Okay? So you would get, I believe, negative 29. Yes? Yeah, that's the same thing I got last time. So I must. Wow. Okay, so that's okay. That just tells you if you have a remainder or not and what that remainder is. But what's more important is this thing called the factor theorem, okay? Because what the factor theorem says is that if you plug in one of the roots, okay, and you come out with a remainder of 0, that must mean that this thing is a factor, and that's why you use synthetic division to find out if something factors or if it doesn't. So use the factor theorem to determine whether the function has factors x minus 1 or x plus 2. So in this case, what I would do is I would plug in a 1 into here, right, for this. So f of 1, in this case, equals 2 times 1 cubed, which is 2, minus 1 squared, which is 1, plus 2, minus 3, which gives you 1 plus 2 is 3, minus 3 gives you 0. Okay? That means that x minus 1 goes into this thing evenly. Okay? So the answer is yes. Okay? If I plug in, what would I plug in to see if x plus 2 is a factor? Negative 2. So I'm going to do f of negative 2. And if I plug in that, okay, I get negative 8 times 2, which gives you negative 16. Right? Negative 2 squared is 4. Make it negative, which is negative 4. Plus 2 times negative 2, which is negative 4 again, minus 3, which gives you negative 20, negative 24, negative 27. So is x plus 2 a factor? No, okay, because you have a remainder. So that's kind of what that remainder theorem tells you, right? Is whether this thing is a factor of this thing. And that is important in finding zeros and polynomial factors of polynomials and stuff like that. So, have you seen this before? Maybe, maybe not. The possible rational roots, you know what that means? You know what rational numbers are? Rational numbers are numbers that do it. Irrational numbers never. Okay? So anything that can be expressed as a repeating decimal, like 0.17777, or 0.6666, or 2/3, or 3/5, or 2, or 6, or 1, or negative 1/2. All those things are rational numbers. Okay? So this little theorem here tells you all the possible combinations of rational roots. So I'm going to, and the way you find that is the factors of p. This is p over here, and this is q over here. P is your constant term, and q is the coefficient of your highest degree term. So I'm going to take a picture of this so that I can make it bigger. Okay? So partial, I want to place a capture new page, partial. I'm going to go like this. Make it bigger. There we go. Move this thing. Can I move this thing? Where did it go? Does it go here when I do that? There it is. Oh, now I got this good. All right. So the p's in this case, these are the p's. Your p's are all the factors of 6 or negative 6, or all the factors of 6. What are some factors of 6? Yeah, so you could have a plus or a minus 1, a plus or a minus, what else? 2, a plus or a minus 3, or plus or minus 6. Those are all your P's. Okay? Have you done this before? Yes. Maybe, maybe not. Your Q's, okay? Your Q's are all the factors of the coefficient of the highest degree term. So what are your Q's? Plus or minus 1, plus or minus 2. Okay? So what this theorem says, the rational roots theorem, is that all the possible roots are combinations of these numbers over these numbers. So the first one, or one of them, would be plus or minus 1 over, I want to start with the smallest one, over 2, which is plus or minus 1/2. You understand that? It's 1 over 2. Yes? And they could be positive or negative. What's another one? Plus or minus 1 over 1, which is 1. Right? This is the way I do it. Okay? Then I go to the next thing. 2 over 2, which we already have, right? Or 2 over 1, which is plus or minus 2. Okay? Then I go to 3. Well, there's plus or minus 3 over 2, which we don't have yet, right? Plus or minus 3/2, and that's a rational number, and plus or minus 3, right? And then I have plus or minus 6 over 2, which would be 3, which I already have, or plus or minus 6. You understand that? These are all my P over Q's. Those are all my possible rational roots. So why would I want to know that? Because I want to see what the roots of this polynomial function are, and I want to do that without a calculator. Okay? Now, since I'm a cheater, do you remember synthetic division? Okay? The way you do this is you take this function right here and you put one of them out here. So I'm going to put 1 out here. Because I always try 1 because a lot of times 1 just comes and it works out okay. Okay? So I'm going to put 1 over here, and then I put the coefficients in order. Okay? And if I had no x term, I would have to write a 0x there, right? And if I had no constant term, no number here, I have to write a 0 there. And then I go like this. And really what you're doing when you're doing synthetic division, you're doing long division, but you're just doing, it's just a shortcut method that works. So with synthetic division, you remember, you bring this straight down. Yep. And then you multiply this number times this number, and you get 2. And then you don't subtract, you add. Okay? So that gives you 13. And then you multiply this times this, which also gives you 13. And then you add these two and you get 6. And then you multiply this times this, which gives you 6, and you put that there. And then you add these two and you get 0. And this is your remainder, which must mean that what? That x minus 1 is a factor, that 1 is a root, also known as a 0, also known as a solution to an equation, also known as a place where the graph crosses the x-axis. Okay? So far, what I have is this thing factors, this equation factors to x minus 1 times, these are the coefficients of what's called the reduced equation, or the quotient, okay? 2x squared plus 13x plus 6. See that? Okay? And then, plug in. And then you can either do this again using the numbers 2, 13, and 6 and putting all these combinations out here, or you should try to factor that, because that's the easier way. Okay? So this x minus 1, I happen to know since I'm good at algebra, and I used to be good. 2x plus something and x times something. What has to go here? 6 and 1, right? So now, what this tells you, okay, is that all the roots are, if I set this equal to 0, the roots, which are also where my graph touches the x-axis, are x equals 1, x equals what? Negative 1/2, because I set that equals 0, and x equals negative 6, which if you look up here, there's my negative 6, right? There's my negative 1/2. So those are all possible rational roots. Now it says sketch a graph. Doesn't it say sketch a graph of this? It doesn't. If I did want to sketch a graph, which I'm going to ask you to do eventually, okay, or is all you have to do is, here's 1. Let's say this is your point 1. Negative 1, negative 6, let's say it's over here. Negative 6. And then negative 1/2 would be somewhere over here. Okay? And what I know is that this thing looks like a cubic function. What do cubic functions look like? Yeah, a positive cubic function starts down and ends up. So just to sketch a graph of this, I could find the y-intercept, but that gives you, it should look something like that. I don't know what my maximums and minimums are, but it should look something like that. Guys? All right. I'm not done yet. I could teach you the intermediate value theorem in 4 minutes. Okay? All the intermediate value theorem says, and this is another way of locating roots. Okay? It says that if you have a continuous function where a is less than b, and if there is a sign change between a and b, okay, then if the function changes, if there's a sign change between a and b, there has to be a zero between those two numbers for the function. In other words, here I have f of a. If I plug in f of here's 0, right? And here's 2. Got it? There's 2. Okay? So f of 0, you guys can do that really quick in your head. What's f of 0? No. 0 minus 0 plus 0 is negative. Okay? F of 2 is a little bit more complicated. F of 2, what's that? 8 times 3, that's 27, right? Tell me if I make a mistake. You're right, 24. Go away. Go away. Go away, I said. Uh-oh. It's gone. My eraser isn't working. I'll get it. Don't worry. But let me finish, okay? 24. 2 times 2 is 2 times 4 is minus 8 plus 2, right? Minus 3. Yes? So you get 24 minus 8 is 16 plus 2 is 18 minus 3 is 15. Okay? So I have a point on this graph here, and I have a point on this graph here. Okay? What the intermediate value theorem says is if this function is continuous, that means and all polynomial functions are continuous, whatever it's doing anywhere else, if this function changes sign from here to here, then there must be a 0 between 0 and 2. You understand that? So if the function changes sign between those two x values, it changes from positive to negative or negative to positive, somewhere between those two numbers it must cross the x-axis. Okay? And that's what the intermediate value theorem is. This is your homework. It's not that much. Okay? So you can do it. I doubt I'll have your quizzes graded tonight. Oh, I have to stop. See, I taught you that in 3 minutes.